Hello, students. Good morning to you all, and a happy, beautiful Tuesday to you all. I hope you're doing very fine at home. I hope you're faring well. I hope the family is okay. Everyone is doing just fine. I believe so. All right. Today is another day in our YouTube channel, and today's class is for those in JS1, and I would want you to pay a close attention to our class today. We're going to be looking at sound and energy transfer. Sound and energy transfer. This is your science physics. I want you to bring your science textbook, your Activate Science textbook, your science notebook, your pen, and probably your pencil, because you have some drawings to make over here. So it is very much important you do all this. Joel, Brian, Tanya, Wansiman, Braulio, and Maria Dolores. I hope you all are doing very fine. Hope you're fine, yes. So without wasting your time, without wasting our time, I would like us to move to the topic of today. Before we go into anything, we need to know what is sound. Today, under our topic, we have some subtopics like sound, sound wave, how sound travels, how fast sound travels. We're going to be looking at those things today. We need to know everything that has to do with sound, and that is sound, the wave, how it travels, and how fast it travels. And I would want you to pay a close attention to everything we're going to say today. In as much as you are not in the class with me, obviously we can learn from this medium, knowing that distance is not a barrier. The only thing is your attention and your... Do you understand? Okay, let's make the class interactive. Previously, we've talked about waves. We talked about different kind of waves. And today we want to look into much more about sound wave. That brings us to what sound is. We say that sound is a vibration that propagates an acoustic wave through a transmission medium such as gas, liquid, or solid. What are we trying to say? Sound is a vibration. Okay, now before you make a sound on something, there is something that must happen. As I'm standing now, if I keep quiet, you will not hear any sound, right? If I don't hit my leg on the ground, you cannot hear any sound. If I don't hit something on the wall, you will not hear any sound. So there must be something that happens for sound to do what? To occur or to happen. For us to get a sound. So now we say that it's a vibration that propagates an acoustic wave. How? Through liquid, gas, or solid. That is to say that sound can pass through solid. It can pass through your wall. When you hit something on the wall, when you hit something upstairs, the people downstairs will hear it, everybody will run out. What is happening? What is happening? because the sound traveled through the wall. I don't know if I'm communicating. And we also say that it passes through the liquid, through your water, and it passes through gas. So it depends on the medium that you use. Okay, sound wave. This is a wave of compression and liquefaction by which sound is propagated in an elastic medium such as air. Air. Did you hear the sound? O. Air. You can hear sound, right? Where is it? What is helping it to pass through? Air. Now it's air that carries sound down to wherever location or wherever it needs to be heard. I can make a sound from this class from here, and someone in primary 1 class will hear me. Why? The air carries it. I don't know if you're getting it. That's the reason why you can be in the parlor and you call your mom from her bedroom and she will hear you. Mommy! See the sound. Okay. Now let's look at how sound travels. Okay, before we get to how sound travels, we need to know what produces sound wave. What produces sound wave? Like we said earlier, that sound is a vibration. Sound is a vibration. So now what produces sound wave is vibration. Now a vibration produces sound wave. All speakers have something that moves backwards and forward or vibrates. There is no speaker that you use, there is no speaker that you have, even your headset. As you put on your headset or when you connect your music to your Bluetooth, for those that have this small kind of Bluetooth that you use in the house, or the speaker, your home theater that you use in your house, or your headset, your earpiece, anyone at all that you use, when you connect your music, when you on your music and you're trying to play the song through the speaker, you will see the vibration. I don't know if you've seen such thing before. It happens daily. It happens anytime you're using your speaker. The vibration must be there. So it's obvious that there is something in that speaker that moves forward and backward or vibrates. We see them always, especially when you connect your speaker and you're listening to JS1 you'll be seeing the sound bing, 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 bing on your speaker like that. Even if you've not noticed such thing, after this class today, you can go back and do the practice. You can go back and do the practical. You will see what I am trying to illustrate. Now, what causes those things? Vibration. Don't even communicate. Please, if you don't understand anything, as you listen, please try to send a message across to my personal WhatsApp number. Very, very important. Don't forget to do that. It's very important. If you don't ask me any question, I will ask you my questions during the exam. And remember, when you don't ask any question, it means that you understood everything that was taught. So when you understood everything, you can answer anything at any time, right? So please, try as much as possible to throw in your questions. I am there to answer. Okay, let's proceed down to how sound travels. Now, when you want to travel from Equatorial Guinea to Spain, there must be a means, there must be a way for you to travel, right? When you want to travel from Equatorial Guinea to Nigeria, there must be a way for you to travel. When you want to travel from Equatorial Guinea to Cameroon, there must be a means for you to travel. Now, how do you travel? Some people travel by ship, by air, by land, different ways. Okay? So now, we want to see how sound travels. Not this time around, it's not how you travel, but how sound does what? Travels. Okay. We said that sound needs a medium. As you need a medium to travel, as you need a means to travel, that is how sound needs a medium, such as liquid with We've said it earlier here, you can remember, right? Such as liquid, solid, or gas to travel through. Where there is no vacuum, where there is no space, sound cannot travel there. Where there is space, rather. Now, when you go outside, let's take for instance, you're in the class and you make a noise. You see that the sound will take over everywhere. But when you go outside, like let's take for instance our farm. When you go to the farm and you make a noise, it will not travel fast, to not travel the way the one you made in the class will travel. I don't know if you're getting it. Because you were on a space. There you are in a space. There is no wall. There is nothing. But here, any little thing you do, it will be heard. Any little sound you make here will be heard. But if you're in a space, in a vacuum, the sound will not be so loud. It will not be too out the way it is inside here. And that is why we say here, sound cannot travel through empty space, like outside. Okay? Because there are no air molecules to vibrate. I don't know if somebody is understanding me. If there is any confusion, consult teacher Queen. So it's very, very important you get to know that. Alright, back to how fast sound travels. How fast does it travel? Does it walk like as slow as a snail, or does it run fast? Let's watch. Sound travels at 340 minutes in air. Sound travels much faster in liquids. We said that sound travels more faster in liquids. Sound travels fastest in solids. Sound travels fastest in solids. In metals like steel, it can travel 5,000 minutes. Sound wave travels faster in a solid than in a gas. Alright? Because of particles. The particles in a solid are very close together. Now, let's get something here. When you look at the particles in a solid, when you see a solid like wall, table, mention them. You can be able to, your stone, things like that. The particles are together. Alright? There is no space. There is no vacuum. All of them are together. Now when you make a sound, like let's take for instance, when an elephant gets a sad or a negative sign, he hits his leg on the ground, boom, so that the other elephants can get the signal and take cover. Now when he hits his leg on the ground, you will see that the sound will transfer, will pass through the ground, and other elephants will get the sound. Now what are we trying to say? We say that the solid have particles, and the particles are together. Unlike other mediums, like liquid and gas, they're not together like solid. Now we have some instances here. This is solid. If you watch, you will see that the particles are joined together. Alright? And it makes the sound move more faster than that of liquid and gas. Now obviously you see how gas is scattered. You see. So you will see the difference. See liquid. Liquid is not together and is not scattered. It has little space, but at the same time together too. But solid is more joined, more in unity, more united than in us. Alright, students, I think we've gotten something today about sound. And please don't hesitate to read more. Don't hesitate to go back to your textbooks so as to get much more points, much more facts. Alright? In order to know more about sound. If there is any spelling, any English, any word, alright, that you don't understand in this particular topic, try as much as possible to reach out so that you can be helped. Okay? We are here for you and we are always here for you. So please try to do your homework, go to your Science Activate Science textbook, page 126 and 127. You answer the A, B, and C. They are very simple. Very, very simple. You can always do them. But if there is anything that you don't understand in those questions, please try to ask me. Don't forget, my WhatsApp number is always open for you at any time, even at midnight. I'm there for you. So it's nice having this class with you. It's nice learning with you. It's nice studying together with you. I hope to see you next time on Thursday. Please, it's very important you copy these notes inside your notebook, your science notebook. Don't tear out a piece of paper to copy your notes. Don't do your homework on a piece of paper. Do them in your science notebook and bring them on Friday for marking and recordings. So that if there is anything you want to ask me, we can talk about them anytime. Maybe if it's something that you want to talk to me face to face, you can come around on Friday while we talk. Alright, thank you all for your time and for staying with me. Make sure you always tune in. Make sure you always go to the classes on my YouTube channel. Bye, and I love you all so much. Do have a nice day, an amazing day, and a wonderful day.